Yeah, welcome to the second part on MLT-Telos, an implementation of the multi-level theory MLT star, which is used to extend conceptual modeling languages by multiple abstraction layers that can interact with each other. So the um, demonstration is based on the paper here that you can download from this page, conceptbase.sourceforge.net/mlt-telos. Um, all the sources are provided here, and also so-called graph files that you can directly execute if you install ConceptBase from this download page here. And you should configure it to start up the graph editor whenever you open a graph file. So I assume that you have either read this paper here or see that you have seen the presentation on this paper. So this web page contains the examples. The first one is just a reminder of what the underlying language of ConceptBase offers for multi-level modeling. So I just clicked on this graph file, and then the graph editor shows up. And well, in OTelos we have the most general class proposition that stands for any factual information, an object or a class or an attribute of an object or an attribute of a class. Even instantiations and specializations are instances of proposition if they are factual information. Here you see an object, Mary's car, declared as an instance of car, and Mary an instance of adult person, and then there's an ownership relation declared at the car class, which is instantiated here at the object level. So this is an instance of that class, which itself is a specialization of the product class. Product class also has an owner relation that goes to person, and that is refined at the car level. So refinement is done here by a specialization. These blue links are the OTelos specialization. So we have here instantiation, specialization, and attribution or relationships that are defined here. We also have a so-called meta class. So product is an instance here of a meta class entity type. You can have any number of instantiation levels. You can also see that as a textual definition. Let's make a larger font. So we declare just entity type without further properties. Product is an instance of entity type, has an owner attribute. Well, we don't distinguish attributes and relations in OTelos, so it's just here an attribute. Person is an entity type. Adult person is a specialization of person. Car is specialization of product, and we refine here the owner relation by this statement. Mary is an example of adult person, and Mary is the owner. Mary's car is an instance of car, and the owner of Mary's car is obviously Mary. So let's remove that. So all the black instantiations are explicit instantiations. If they have this grayish color, then they are derived by some rule. So for example, if we check the instantiation of Mary's car, then we see it's also instance of product, and that's a derived link, and that's a built-in rule. If an object is an instance of a subclass, and it's also an instance of a superclass. That's a built-in rule of the MLT-Telos language implemented by ConceptBase. So that's basically the capabilities of ConceptBase. So now let's go to the MLT-Telos demonstration. So that's the first example. It starts up a server and tells all the definitions. So these graph file contains are self-contained. They contain all the definitions that are necessary to work with that. Let's make it a little bit bigger. So the new construct of MLT, of multi-level modeling with power types, is this power type relation. The person type is declared to be the power type of person. And we have two explicit instances of person type, man and woman. So these are explicit instances. And then the power type rule of MLT-Telos says, instances of the power type are subclasses or specializations of the type that the power type points to, that it is a power type of person. So these gray links here are derived specialization. You can also see that here. Superclasses here are, superclasses are not that are, sorry, outgoing attributes are this. So it's a superclass of itself and also person. So the specialization link of MLT-Telos is reflexive, so each class is a specialization of itself, but this one is derived because of a rule here. This derived specialization works like the normal specialization. So an instance of a subclass is also an instance of the superclass. So that's this instantiation link, so that all the gray links are derived. Basic type is not of great importance here, that the original MLT star papers defined what a basic type is. So these two types are basic types, and for example this one is not a basic type. It's a type but not a basic type. Again, the factual information of that is just this. So you declare person type to be a power type of person, and you declare man, woman, person, and then these individuals here. You can also see the definition of MLT-Telos. So go to the MLT-Telos module, and there you see the full definition of MLT-Telos. It's also in the paper and in the original presentation. It's not a very long definition. That's for the categorization, and the rest here is just the graphical types that we use here to visualize models. So it's important to know that this is the visualization of the model that is stored in the database. Let's add some instance. So let's say Julia. I misspelled that. That's instantiate that to a woman, and also maybe this So we also have to instantiate that to individual. So same class here, so we also have to instantiate that to individual. And now we commit these changes, and now we no longer need this to display this one here, and we have a new instance of woman. That's also an instance of person. I'm not showing that. So let's go to the next example. So you see the textual definition also here on the web page. This is about categorization, for example, disjoint and complete partitioning of a class. So we have here the power type declaration as before. In addition, we might use partitions or disjoint or complete decompositions of classes. So for example, person by gender can be used to partition the person class. That man is also instance of person by gender, so that was not shown in the view, but it's in the database. In this case, we have a violation of the categorizations constraints for partitions. There's one object, Anna, that is in both subclasses, so it's not disjoint. It's declared to be a disjoint categorization, but it's not disjoint, so that is indicated here. And it's also not complete because we have an object like this here. We can also do the same in the textual window. That's the definition of incomplete categorization. So there's some entity that violates that, and we would like to see which one, and we just ask this query, and we can see that person is a class that is not completely categorized because there is this witness data. That is how you could use queries to analyze a model for violations. Let's go to the next one that is slightly more complicated partitioning. So note that we always tell the whole definitions here. It takes a few seconds and then we have it. Here we have a living being type to be the power type of living being. So that is defined at a more abstract level. And then we have person type, and there we have person by gender to be the type where different genders of persons can be instantiated to. Like in the previous example, it's man and woman, and again we have this partitioner link that now goes from this subclass person by gender to that subclass. Maybe one thing here, plant is another subclass, but it has no instances in the original MLT star. This would not be a type, so we can detect this because it is instance of a type without an individual. So it's declared to be a type, but it doesn't yet have an instance here, directly or indirectly. Next example is multiple generalizations. I guess I don't have to start it up. You see that adult man here is having two superclasses. That's also defined here. Next example is ordered types. That is the use of power types to enforce some levels in a multi-level model. So individual stands for objects. In UML terms, this would be M0. That is for first order types, so that would be M1. That is for second order types, that would be M2 in the UML language. So order type are those that are in these power type chains, and that is detected here. The subclasses are also then ordered because this order enforces that order. An order type is essentially a chain that starts from individual, and there shall be only one chain because power type is a one-to-one relation. So there cannot be another power type of individual. Once you have this one, there cannot be a second one. Yeah, the rest works in a similar way. Let's look at Bob here. So in the previous examples we had to explicitly declare that Bob is an instance of individual as well, but due to this power type relation, all instances of first order type will be subclasses of individual, so it automatically gets populated by such instances here. Next one and last one, that is the mapping of DeepTelos into an MLT model. DeepTelos is also a power type related multi-level modeling language that was in the first instance already declared within ConceptBase, and we used the experience with DeepTelos to realize MLT-Telos. Since MLT-Telos has more constructs, in particular the categorization, DeepTelos can always be embedded into or seen as an MLT-Telos model, and we do that by deductive rules that derive the power type relation from the counterpart in DeepTelos. So that is the original DeepTelos model. Here's a power type chain, and you see here that you can declare attributes and relations at different abstraction level. Here at the car model level, which is a meta class, it's an M2 level class, and it is instantiated here for this Porsche 911. It's a simple class, M1 level. At the same time, you can have car to be pointed to by car model as a power type of car model is a power type of car, and then you can define the owner relation for car. In other multi-level modeling, you would regard this as one class, car model and car, and then define number of doors and owner at this single class and give them so-called potencies. That would have a potency of 2 and that a potency of 1. Good. That finishes this presentation. So when you want to check it out yourself, then follow this download link, install ConceptBase, make sure that it starts up the graph editor whenever you click on a graph file like this one, and then you can inspect the examples, so-called Gale files, like we did. So these are all the examples that I showed you, and you can run them all. Thank you.